Kia ora, ko Rachel Cookson toku ingoa. Thank you, Michael, for that introduction. So Angela and I, as Michael said, are going to talk through NCEA course planning with a science of learning lens. Through this presentation, we are going to ask you to do a couple of Menti questions. So if you can make sure you've got your phone close by so that you can enter the Menti code and get answer some questions and give us some feedback, that would be awesome. And also at the end, we'll do a little reflection activity. So if you've got a pen and some paper close by, just to jot your thoughts down, that'll also be helpful. So just in preparation for when we get there. So I'm going to go through some initial kind of scene setting. Angela's then going to look at a couple of the science of learning principles and some course design work with you. I will then finish off by just reflecting on cognitive load and how the science of learning principles can be used to support reducing too much cognitive load on young people as part of our course design. And we'll have some opportunity for reflection and questions at the end as well. So starting off with NCEA Level 1, it's important to know what we're talking about when we're talking about NCEA Level 1. So part of our new Level 1 is we have the Whakatoki for Maths at NCEA Level 1. We have 5 big ideas, 6 strands of content, and you'll all be familiar with our 6 strands of content. That is slightly changing and merging the naming of them in our curriculum document, but we've got our 6 strands of content for our level 1. 9 significant learning aspects. These are the bullet points on that learning matrix. And 32 weeks approximately to teach that material, to teach that information. So which makes it really important. And I say approximately because we're very mindful that all kinds of stuff happens in a school year. So why the science of learning? So the Ministry of Education, the minister has provided us with 6 education priorities. And the top one there in the education priorities is a clearer curriculum, establishing a knowledge-rich curriculum grounded in the science of learning. So it's very evident through a number of the initiatives and strategies and interventions that have come through recently from the minister and from the Ministry of Education that science of learning is a priority. And we'll look at a couple of examples of that in a moment. But also our curriculum documents talk very much about the science of learning at the forefront of the refresh documents that we've seen English and maths coming out recently. So what is the science of learning? So the science of learning, you'll see kind of on the left of the screen there, that is a quote from Te Mataiaho with the English curriculum. So the refreshed curriculum that's currently out for review for year 0s to 6. Science of learning helps teachers understand how students learn biologically, cognitively, culturally, emotionally, and socially. Very large definition. I think the key thing when we're talking about the science of learning is to understand that this is not a done deal. This is a body of ongoing research around how young people learn, how we all learn. And our intention is to use that knowledge of how we learn to create courses so that students can access the content and build strong foundation of knowledge at NCEA Level 1. However, it is really important to be mindful that the art of teaching is still very much present in what we're doing in Aotearoa, New Zealand. Young people cannot learn if they are hungry. Young people cannot learn if they are not ready to learn. So it is important that this is not one or the other. If we just did the science of learning, we could be going just only focused on scientific principles. We could be going a left turn round and round in circles. If we only focused on well-being, we'd be going round and round in circles in the right way. So by using both the science of learning and the art of teaching and understanding where our young people are when they arrive in our classrooms and in our school, we're able to move forward and develop that learning. So as I mentioned, there are some examples of science of learning principles that are coming through from the Ministry of Education. So this is just an example of a few that I wanted to highlight. So the hour a day of reading, writing, and maths is about that structured approach, that spacing of learning, which we will talk about a little bit more. The scope and sequence that you'll see through the documents as well. If those of you who've already had a look at the maths curriculum, you'll see the scope and sequence of what students should be exposed to, what's cognitively appropriate, and moving through sequentially, building on that learning, activating the prior knowledge as we go through. Structured approaches to literacy and structured approaches to maths. Very clear how we're going to teach, being explicit in what it is we want students to learn, and how best to support them. Using data to inform our practice. So using information so we know that where young people are and what we need to do to move them forward through the curriculum and building their knowledge and understanding. And positive relationships is very clearly discussed in the curriculum, the maths curriculum document that has recently been through a review. Feedback is now closed, but that was very much clear through the document. So that's kind of where we are. That's why we're here today, why we're looking at the science of learning. So I'm going to pass over to Angela, who's going to just have a discussion around the science of learning and how that applies to course planning.
Those of you that have been in schools where in previous teacher-only days or during staff meetings you've been exploring some of the science of learning principles, you may have seen the list that we've got on screen here. And possibly you've seen the cutout with the definitions of them and how they might, some examples of how they might be implemented. What we've decided to do is focus on a couple of those that particularly relate to course planning, but we're interested to know how many of you may have heard of some of these or are aware of them in terms of the science of learning principles. So we've got a Menti that we're just going to ask you about. Here's the code for it. If you could just start that and see if you can just give us an indication of which ones of these things that you are familiar with. So hopefully let us know if you can access that question. It says responding's off, so that...
if you haven't done a Menti before, team, it's easiest to do it on your phone. If you just go to menti.com and type the code in, it's a lot easier.
So there are a few places where we will, and I think there's just 4 questions at different times, and we will just let you have the opportunity to respond to those. And yep, we can start to see that if people are familiar with them, what will happen is you'll get a little box pop up on screen about, yes, here's are the ones that people are most familiar with. So far it's showing me that we've definitely got most of that top line. Awesome. Cool. Okay, so based on that and kind of how we were wanting to frame today's session, we were particularly interested in a couple of concepts that would allow us to think about when we are looking towards 2025. We've all had a go at our teaching and learning this year. What we could consider from the science of learning lens in terms of redeveloping or looking at our courses. So the first section, we're just going to look at it about activating prior knowledge and space practice. So Rachel, if you could. So we have been out there talking to teachers for the last year or so, and before people started and while they've been doing the implementing, these are some of the things that we've been hearing people say. A lot of people are reflecting to us there's quite a lot of content. We know that level 6 of the curriculum is quite wide, and the learning matrix does narrow that down a little bit. So for example, circle geometry is part of level 6 of the curriculum, but it's not within the learning that should not be left to chance. So it's not considered an essential component that was within the learning matrix. So when you're designing your courses, it might be something that you put in or not put in, but it fits with level 6 of the curriculum. So we've been hearing people say lots of content, that we've had people reflect on statistics taking up a large portion of the course, that trying to fit it all in has been a bit difficult, and considering the interruptions and things in the school year. So those are some of the things that we've been hearing. The next thing I'd like you to do is, can you tell me, for you, thinking about next year and what your experience has been during 2024, are some of these things something that you're considering when you're re-looking at what your course might look like for next year? And we put other in there because there is always different things going on in different classrooms. So have a go. What we're asking you to do is to rank those, rank which ones are the most challenging for you. And if you have got something in the other category, please pop it in the chat and just let us know what other things are challenges when you're thinking about designing your courses. So I'm hoping that people are able to respond to that question. Okay, yep. Definitely something I've been hearing is that students are not at curriculum level, and therefore not only are we trying to teach everything that's in the learning matrix, but we are trying to make sure that we are covering material potentially from level 4 or 5 of the curriculum before we're getting the students to be able or ready to experience the material at level 6 of the curriculum. Yep. Cool. Okay, so if we think about those, feel free to keep adding your answers to those. And those are some of the things that we've been thinking about as we've been trying to work out and work with teachers about what, reflect on this year. We've all had to go, what do we do next? So Rachel, let's flip forward. We've also had people telling us that they've had some positive experiences with the refined NCEA level 1. In particular, they've found the opportunities that there is some connections across the strands, or being able to make links between things, because they're not teaching a unit on measurement, assessing measurement as a particular unit, and then separately doing a trig unit. And the connection between things is easier in the NCEA new format. So the idea that we can repeat some of the things that you're doing, the big ideas, are being developed across the course. So not only have we had challenges, but we have had people saying to us that there are opportunities in the new NCEA level 1. So let's just look about activating prior knowledge, and particularly spacing in terms of the course design. So here we've got the diagram that some of you will have seen from Nina Hood's video, and essentially it's saying to us that if we have new information, that it's best understood where the students have and can connect it to existing knowledge. So we've got those grey blocks or grey triangles showing up there. That's the students' existing knowledge, and we are then able to add new knowledge to that. And if we've got a strong foundation of those grey triangles there, the new knowledge just sits there more solidly. So if the students have existing schema of something, they will be able to build on that and add to it for their new knowledge. So, for example, in a maths context, if a student has an understanding of a quadrilateral, they can then build on that by adding concepts of equal angles or parallel sides, equal side lengths, and then they can develop the different sorts of quadrilaterals because they've had an understanding about that initial shape that they're adding to. One of the key things about prior knowledge and us activating it for our students is that if we are able to know that students have prior knowledge, it is one of the key predictors that helps us make sure that students are going to be successful learners in the future. So studies are showing us that if we activate that prior knowledge, we are going to build stronger connections, and the students will more likely learn the material that we are trying to get them to develop now. It also says that when we activate prior knowledge, we're not just thinking about academic knowledge, we are thinking about other sorts of knowledge that students might activate when they bring it to their learning. So that's the idea that if it's high interest for a student, or if it's culturally or socially relevant to them, they bring that prior knowledge with them to the learning context. And obviously that's why we've tried to use themes or ideas where we connect it to a sport a student might be interested in, or connect it to a group of students that are interested in a particular topic as we try and connect our maths to the real world. So to just put that in context, here's a study. It's often called the baseball study, and it's Rick and Leslie have studied prior knowledge, and this was one that was done in the context of reading comprehension. So the students were given a paragraph to read that was about baseball, and there were two groups of students involved in the study, those that had a high knowledge of baseball and students that had less of a knowledge of baseball. So basically people that were interested in that sport and those that weren't interested in that sport. Both groups of students were asked to read a passage about a baseball game, and then they were assessed on their ability to recall or process information in the context of that. Now, probably not much of a guess about which students are likely to do best in that reading comprehension or being assessed on their reading comprehension. So the ones that came out on top were the students that had high reading ability, could process that piece of text really well, and also were knowledgeable about the topic. And at the other end, we had the ones that had low reading ability and weren't really particularly interested in the topic. But in the middle, if you feel like adding to the chat, oh no, we've flipped forward. It's okay, keep going, Rachel. We have the two groups. We've got the low reading ability, but really interested in baseball, and the students with high reading ability, but not particularly interested in baseball. And we can see from the study, look at the yellow and the green bar, the students that were interested, we were activating their prior knowledge, they were making connections to what they already knew about the topic. They did nearly as well in this particular piece of assessment, their comprehension of this particular thing, as the students that had a high reading ability. So their ability was essentially activated because they were interested in the topic that we were doing. Now, obviously, we've chosen one study here, but this has been replicated across quite a range of different contexts and topics. And it's just something to bear in mind about how we might approach putting topics within our maths. So I'm not necessarily thinking about the maths content, but the way that we package that maths content for the students. The second component we've got here is a spaced practice concept. So here's another piece of research that is talking about development of vocab on a particular thing. So we've got students that are trying to develop some vocab knowledge, and again broken into two groups of students. One group of students were exposed to spaced practice, where they had 10 minutes over 3 separate days where they were exposed to this vocab exercise and developing their knowledge of this vocabulary. The other group had their 10 minutes, but all within the one day. They didn't know that they were going to be assessed on this content in the future, but an unannounced test 7 days later was given to both groups of students, and probably not a surprise to us if we go to the results of that. The students that experienced the spaced learning opportunities across multiple days had a much higher achievement than the groups that had all of their learning on the one day. Now, obviously, in the context of our course design, we have some constraints for us. We are in schools where a timetable and the way we have things structured across the day may not be within our control, but are there opportunities where spaced practice is something that we can consider in how we revisit topics or consider the options of how we are doing our teaching throughout the year? I'll give an example that I had a colleague a number of years ago, because she was in a school where there were trades academy and gateway opportunities. She had calculus for 4 hours on a Friday, and that was her experience. It happened for a year, and it's probably not much of a surprise that after that year, the school revisited and changed how that program. Now, we're not in control of some of those things, but we are in control of some aspects of our course design and how we might consider space practice. If we just hit, some of you may have heard of Ebbinghauser. Ebbinghauser's forgetting curve over here on the left, and the idea that if you learn something and then there is a rapid decline in how much of that information is retained in your memory, essentially it goes into short-term memory and it's retained. If you revisit that material after a period of spacing, then your relearning up to the original amount is quicker to achieve, but the drop-off, you'll see that the red curve is dropping off more rapidly than the green curves. And after each repeated revisiting of that material, so the spacing of that material over a period of time, the drop-off is less. I mean, ideally for all of us, we'd like our students to come into our Year 12 courses retaining all of the information that they've been taught in Year 11, and I'm not unrealistic to expect that to happen. But I think the key thing is Duolingo, language practices are examples where we know, you get those little reminders on your phone to have you practice today, because that key thing of repeated practice is helping. Down the bottom, you'll see an effect size, 0.71, the idea that spaced versus mass practice is quite has a significant effect size in terms of the students achieving and retaining knowledge. So let's just consider those two concepts in relation to our courses. Here we have on the screen assessment. Okay, so we know we're doing the teaching and learning across the year, but if we look at the course content for 1.2, which is the material on the left-hand side, and then 1.4, you can see that there's quite a duplication of some of the content. Of course, these are assessment opportunities, and assessments are only sampling what happens during our learning. So we're trying to teach the students a broad content, and we will only sample or assess a component of that. And so therefore we can expect across the year, by having an overlap between these two things, there's opportunities for us to design multiple chances for the students to experience the content. And by the time they're getting to that end of year exam period, they may well have experienced quite a number of those things that you see in the 1.4 content previously when you have been doing your teaching and learning towards other assessment components of your course. So I put up a couple of course outlines just to have a quick glance at. So this is a course outline where the teacher has broken it down with the significant learning essentially broken up by the strands that we would expect. So we've got a measurement topic followed by a geometry topic, and it progresses through the year topic by topic. The next course outline that we've got up on screen is a teacher that has considered that not all of the students are coming into their course with the same background knowledge, and they've needed to consider how they would break the course up and bring students from different levels up to the level where they can access the level 6 of the curriculum. You can also start to see that they've broken the course up with a little bit of, can we put some theme-based things in, maybe to activate some of the students' interest in particular topics, or finance, getting their first jobs, those kind of things that are probably relevant to some of our Year 11 students. And then the third example I've just put up, this teacher, again, a little bit of a theme thing coming through, but you'll see that they've broken the statistics. So rather than strand by strand, we've got the statistics investigation part there, and they've chosen to do the time series and bivariate at this point in the year, and then in the full course outline, you can see it revisited at a later point. So just keeping those course outlines in mind, these are some questions that we think are worth reflecting on when you're designing courses. How do you actually capture your students' formal and informal learning that they might bring to the class. So that's bringing in their cultural and social backgrounds, their sports interests, those things that they can bring to the context of a mathematics, but also their formal learning about what skill sets they have from their maths that they've learned in previous years. How could themes-based work fit in? Is it possible that there are some opportunities where space practice can be brought into your year when you're thinking about, we've tried this year, what could we do next year in terms of repeated access or spacing of things, so that we're basically bringing those students up to retain more of the things in their long-term memory. So on the next couple of slides is 2 questions. On your screen, it will ask you with a little bit more of a prompt to remind you of the questions on the slide, but the previous slide, and you will be able to just answer a couple of questions. So we'll give you an opportunity to think about space practice and activating prior knowledge in your courses. I can definitely resonate with the idea that when students are missing class times, I've certainly had year 11 classes with gateway students in it, or students that are out on a lot of sport, that revisiting concepts is a key thing for me, because of the fact that I've had knowing that those students are going to be out and they'll miss content, and we need to, it helps the other students that are there by reviewing the content, but it also means those students are introduced. Oh, an interesting point there about moving assessments to later to get more spacing to combine ideas and avoid messing of things. I have definitely had conversations with teachers where they've had to have a discussion, or there's been school-wide discussions about tracking of students' progress, and they've had to make a bit of a shift this year. Students are aiming for 60 NCEA plus the lit num, and the fact that if the deans are starting to look for tracking of student results early on in the year, that they may not have quite as many credits. We're doing fewer larger assessments, and maybe that's a mental shift that we need to make. And maybe, you know, do schools still have constraints about everybody must have an assessment completed by the end of term 1? And if your school still does have that policy, is it something that, you know, needs to be reviewed or looked at across the school in terms of opportunities that we might have in terms of designing courses? Okay, so you will have access to have a look at the results, and when you get to the end of the Menti, you can get a download of the results. Here's just another one, thinking about activating prior learning. So thinking about designing your course or ways to bring those students up from lower levels. Would themes-based work in your context? I know I've tried themes that have been long themes over several weeks, and then I've also tried themes that activate knowledge or get the kids involved on a shorter basis, partially because I've been wanting to expose a range of students to something that really sparks their interest. But are there opportunities that you think of that where you can do this in your course design?
For me, one of the challenges we've faced this year with a turnover of staff and a lot of new teachers that are new, particularly to NCEA, that sometimes they are not aware of the prior learning that the students are supposed to have had in previous years, and it's all a bit too much, I feel, for them to come in and know what they need to teach in the current course, and also to know what the students are coming with. So I think building that into lesson planning, where sometimes student voice is useful, but sometimes it's not very informative, because a lot of the time students will say, oh, I can't remember anything. That's what I found when I've tried to brainstorm at the start of a lesson, that the top students, well, yeah, they will remember some stuff, and the others are looking at it puzzled, going, my goodness, did we actually learn that?
Definitely.
And sometimes, just to add to that, Michael, sometimes if you start with, do you remember this, and then show a little bit, then all of a sudden light bulbs go on and go, oh yeah, no, I do remember that now that you say X, Y, Z. So it's kind of just, you know, doing that repeatedly. Those checkpoints are really important, and we'll talk a bit about retrieval practice, but yeah, very much the same thing of what knowledge do they have, what prior information is there. The relief teacher discussion has come up in a lot of schools I've worked in, and that you assume that work is being covered, but it might not have always been covered.
I think also just the idea of where did they come from. We need to be mindful that there is a change in the curriculum in the 0 to 8 space. So at the beginning of next year, we've got one more year where our year 9s, we know the curriculum they've come from, but it's probably important to keep our eye on what's happening in that 7 and 8 space as well, so that we know the changes that are happening there when we're thinking about what happens with our year 9 and 10 course design. Okay, thank you for your ideas and thoughts. I hope this prompted a few bits to think about. And now Rachel's going to look at, oh, I think I've probably covered these. Just some things that we thought about the way that we might look back if we were designing a course now after a year's worth of experience, and whether there are some opportunities to do building in checkpoints with revisiting those themes, or the big, and I'm using the big idea theme now, and just spacing the exposure, not necessarily doing the whole of the statistics topic for the whole of term 1, but maybe spacing that out across the year.
Kia ora, thank you. Okay, so I just, and with what we've discussed so far, underpinning the science of learning is the acknowledgement that we need to support students to move knowledge from their working memory into their long-term memory. And that's how we can ensure that when students start our level 2 courses, that we can be confident in saying you've covered this material, and students are able to recognize that they have covered the material because it is in their long-term memory. And so it's easier to put new information, curriculum level 2 content, curriculum level 8, NCEA level 2 content on top of this foundation, if we can be confident that that foundation, that is NCEA level 1, is in the long-term memory. So it's the thinking around cognitive load, and it's supporting getting information from our working memory and into our long-term memory is overarching for everything we're talking about when we're talking about the science of learning. So I appreciate that a lot of people did say that they had some knowledge of cognitive load, but there were also a few there that weren't 100% sure. So just very briefly, just to kind of highlight some things around cognitive load. There are 3 types of cognitive load when we're talking about a student's, 3 types of load when we're talking about students' cognitive load. So we've got the intrinsic load. So that's driven by the material itself. So the content that we are showing in our course. So the information that we are working through as part of our course. And we've discussed previously how students might not have that prior knowledge of curriculum level 4 or 5. So it's the intrinsic, the managing of their complexity is really important. We want to manage to make sure that we are at the appropriate level, that there is some challenge, but not too much challenge. And it's that balance that's really important. And I'll talk a bit around Vygotsky's zone of proximal development, but that's really important that there is some challenge, that it's just not too much. So if we can manage that complexity and that intrinsic load, we can support students with that movement of information from the working memory to the long-term memory, and they don't become overloaded. And we have extraneous load. So that's things a lot that are driven by what's happening outside of the intended learning. So distractions, or you've gone off on a tangent. I'm trying to teach students about adding decimals together, but randomly I start to talk about algebra. And sometimes that can help, and because we're talking about different types of interleaving practice, but sometimes it can feel overwhelming because students are being asked to shift from looking at decimals and looking at the intention of the lesson to something else. An example as well is when we are asking students to work out area, And so they need to multiply in order to work out area, but they don't know the times table. And so we need to be thinking about reducing the distractions there and the noise. It's also around the classroom environment. There's not too many distractions there, so that students can really focus. And this is where that universal design for learning really comes through again. We have domain load. Now, domain load is a bit controversial. Some cognitive scientists are not comfortable with the concept of domain load, but the theory behind it is it's about the ability for people to move from the working memory to the long-term memory. And it's important to understand that some of our neurodiverse students, that their cognitive load becomes overloaded very quickly. And so their ability to move information from working memory to long-term memory can be a bit more challenging. So we want to maximize their ability to move from working memory to long-term memory. And that's why things like our space practice and our activating prior knowledge become really helpful in building students' ability to build a strong bridge between their working memory and their long-term memory. On this slide, we're not going to go through it today, but on this slide at the bottom is a link to a paper by Dr. Vicky Lycoraz. And she talks about the 5 effects of the impact of cognitive load. So if you would like to find out a bit more about that, then when you get these slides, have a look at that link. And they're very math specific, so you can really see how they apply to the maths classroom. So with that in mind, Angela's already spoken about activating prior knowledge and space practice with regards to course planning. It's important to note that these practices help reduce cognitive load by reducing the intrinsic load due to the use of prior knowledge. So if we've got prior knowledge on the topic or prior knowledge of the context, then we can link new information onto that and it reduces that intrinsic load. It doesn't feel so complicated and complex. We're building and we're scaffolding on from prior knowledge to new information. So we're not feeling overwhelmed cognitively. And also, if we think about the use of space practice, we can think about delivering content bit by bit, and students are therefore not only are they going to be able to go and revisit and build and strength, but also they're not feeling overwhelmed with one block of everything you need to know about linear algebra all in one session and then it's gone. So thinking back to that the diagram that Angela showed us before about the forgetting curve. So with regards to 2 other aspects, principles that we had up on the screen before, we've not quite covered these, but I feel it's important to just refer to them. I think it's because retrieval practice interleaving feels very much more on the lesson level. So what it is important to think about from a course planning perspective is to think about deliberately designing time in our courses so that we can embed some retrieval practice time and some interleaving. So I think retrieval practices people are fairly familiar with retrieving information, but interleaving sometimes people are a little unsure about interleaving. And I noticed on the votes that was fairly low as something people were familiar with. So interleaving is the idea of mixing different types of content knowledge. So learning about different aspects. So the practice of interleaving is really important for students. If we think gets back to an NCEA and assessment point of view, think about 1.2 assessment. The 1.2 internal, we've got one large problem, and in that problem is different types of skills, different elements from different strands. So by incorporating in our course design some time when students will be taught the separate bits of strands and information that they need, but then there is periods of time, a lesson or 2 every now and then, where they're given a range of different questions and they're having to then work, okay, so this is I need my number skills. I need to know how to work out the surface area, and then I need to know how to work out the cost that I'm going to need for the materials, and I need to add GST. So we've got 2 different strands there. We've got our measurement strands and we've got our number strands, and we're interleaving those into problems, and we're interleaving those into examples. We need to make sure we demonstrate this to students so that they understand how mathematics and statistics connects. And so a course design that allocates time for this is very important. Students will only know how to do something if they have been shown how to do that. It's really important as part of that practice. And also the interleaving practice of having to, and retrieval, they kind of align together, of having to recall information from the lesson when we were taught about volume and the lesson we were taught about how to work out GST. We're having to retrieve that information and use that in a combined way. That's going to have an impact on cognitive load. And so it's about that balance of easing students into it. So the complexity of the task becomes increased because I'm having to use different pieces of information. I'm having to access content from different places. But there's nothing wrong with giving a bit of stress and a bit of load, because that is when learning happens. But we just have to be very mindful about putting it into our course. So just briefly, I added this slide. I know we're all familiar with Vygotsky's zone of proximal development, but I just wanted to put this here because I wanted to highlight that when we're talking about the science of learning, we're talking about a body of research that's been around for a long time. And as maths teachers, we're very mindful of the importance of scaffolding. Maths teachers are very mindful about the importance of worked examples, about leading students step by step and scaffolding through the work. And this is very clearly evident through the principles of science of learning, as it all aligns. It's not an extra, it's not an add-on to practice. It's very much about doing what we're already doing, but with the knowledge and understanding of what works for learners and how to best support them and design our courses with that in mind. So,
Rachel, just there's one question in the chat which refers to the previous slide. I thought it's a good one. Would it be fair to say that retrieval is linked to activating prior learning and spaced practice is linked more to interleaving?
linked, yes, you're right. These concepts are very much overlap with each other. So the key thing with activating prior knowledge is that we are using previous information to build new knowledge on top of. Whereas retrieval practice is about the same information being practiced, mastering the same skills and same processes, so that I'm constantly remembering. I remember them. The retention is there. The kind of difference between space practice and interleaving is space practice is about learning the same content, but like retrieval practice, again, they all intertwine, same content in repeated sessions, but separated with a certain amount of time, so that students might have forgotten a bit and then they're revisiting it. They've forgotten it. So it's retrieval practice is happening in the student, but the space practice is what's happening with the teacher, if that's clearer. The interleaving is about different bits of information, different concepts. So we would have learned about a particular skills in one lesson, learned about other skills in the next lesson, and then the third lesson or follow-on lessons, we would be mixing up the different skills. So the student has to learn which skill am I using when, and if I want to solve this problem, I need to pull from things I learned last week and things I learned the week before and things I learned yesterday, and being able to pull all that together. So yeah, they very much, complement each other. Yeah. Good question. Good question.
Thank you.
Yeah.
Thank you.
Yeah, and we just added on to the slide deck, just really for you as a resource of some suggestions and ideas. And again, this is very much from a classroom level rather than a course design level, but some examples of scaffolding and organizing giving students an opportunity to revisit, so that activating prior knowledge, that retrieval practice opportunities, Michael talked about it before, you know, asking students what do they remember. If we're doing that in different ways and we're checking in different ways, we can collect that rich information, whether it be through data, through numbers and literally answers to questions, or whether that be students' reflections. Both are really important. If we can collect that information, we can use that in our course for retrieval practice and for activating prior learning. So we're drawing very close to a close. So this is where you're going to need your pen and paper. And we're just going to give you a moment to kind of reflect on everything that's been said. We're conscious of the amount of information we've thrown at you. So in a minute, so I need you to get a pen and some paper. And if you've written any notes, just kind of put them away, because we want to kind of cognitively engage. And I'm going to give you a couple of steps in a moment. And I'll just give you a second to get your pen and your paper. Okay, so these should have been one by one, but if you just listen to the instruction, that'll be easier. So I want you just to take a moment. Don't write anything down at this initially. I just want you to take a moment to think about everything that's been said today. What did you think about it? What have you heard? Just take a moment to think about it. Okay, now with your pen, jot down on your piece of paper key words, key phrases, things that really struck you, and you think, oh, I hadn't thought about that before, or what might you take away and look at your course design. So just jot down keywords, terms. Okay. And the last point, the review and connect. Thinking of what you've just written down, all those words and those thoughts that have been through your head, what's one thing you might go find out about next? What's one thing that you might ask a question about? What's one thing that you might go talk to your team at your school about with regards to course design? So one thing that you're going to take away from here. Okay, we'll leave it there. I would like to close this with a karakia, but I think people may have questions before I close with the karakia. So I'm just going to pause for any questions for Angela and I, and then I will close with the karakia. Is there anything, Michael? I can't see the chat.
No, not at this stage. Once you have finished with your karakia, I'll just present my screen as well.
Oh, okay. Well, I'll do the karakia then. We'll move forward. Unahia, ke te uru tapanui, kia wātia, kia mama, te nākau, te tina, te wairau, I te ara tangata, koia rā e runga, ka whakariwa ke runga, kia tina, hui e tākie. Thank you very much, team. I will stop there.
Can you see my screen?
Yeah.
Brilliant. Just a quick reminder about feedback, team. If you've got any feedback about this, you're more than welcome to put it in the chat. All the resources to all of these sessions will be put on YouTube at a later date, and also on our Auckland Maths Association website. Thank you so much, Rachel and Angela, for your time today. I particularly appreciated the fact that you are former teachers. You're one of us, you know, like kind of what it's like at the coalface. From the outset, you acknowledged that, you know, the science of learning, it's not one or the other, that there are so many other things that students bring into the classroom that we need to be aware of. And just fixing this is not going to, you know, be the silver bullet. You talked about things like timetable constraints as well. I quite liked you highlighting the overlap between the standards 1.2 and 1.4, the fact that we need to deliberately build in time into our planning for things like interleaving. And one of the things I do in my class each week with my juniors is sustained silent numeracy after lunch, period 5. They come in and they do a bit of numeracy. The importance that we used to teach things in a siloed manner in mathematics, and now the standards are allowing us to bring things together, but we actually have to teach it together. We can't just go geometry, and number, and then expect students to be able to be assessed on stuff together. So I really like that you supported that with research. The different course outlines that you shared with us was actually quite interesting to see the contrast of what schools are doing out there. I think for me, the takeaway is that it's important that we communicate these things with our students so that when they come into our class, they are aware of the rationale behind decisions that we're making. Like, why is it necessary for a maths class sometimes to be quiet? You know, like noise is great, problem solving is all good, but sometimes students do need that silence to be fully focused. Talking about the Ebbinghaus forgetting curve, you know, students are expected to forget some stuff. And if we keep repeatedly practicing things, that is going to support our cognitive load. So yeah, like, I really appreciate the presentation there, and I'm sure everyone else did as well.